Grade 12, let us now look at Physical Sciences, Paper 1, November 2022, question 7, which is Electrostatics. Let us get straight to the question. Question 7, a charged sphere, which is M, is suspended from a ceiling by a light, inextinguishable insulated string. Another charge of sphere N, which has a mass 2,04 times 10 to the power negative 3 kilograms and carrying a charge, so we are given a charge here of 8,6 times 10 to the power negative 8. All right, let's just try and push this down and see what we can have here. Oh, it hangs stationary, so not moving, vertically below sphere M. The centers of the spheres are 0,3 meters apart. We are given the radius there, as shown in the diagram below. Let us go and try and analyze our diagram here. We have our ceiling here. We have sphere M. What we can do in the meantime is to check whether we are given anything on sphere M. Now, on sphere M, we are not given anything, but on N, we are given that this charge here is the same as 8,6 times 10 to the power negative 8, which is coulomb here. And then it says sphere N as well has a mass. We are given the mass of sphere N. The mass is 2,04, so we are given the mass as well. So our mass here is in fact 2,04. So we have 2,04, which is times 10 to the power negative 3, negative 3. We can just fix our 3 here. So it is negative what? Negative 3. Okay. And then it's kilograms. Let us verify again if we are not given anything from M. So M, nothing was given on M. Let's move to our questions now. Now 7.1 says state Coulomb's law in words. State Coulomb's law in words. Now, this for 2 marks in the exam. Coulomb's law. How do we then state Coulomb's law? We must come to Coulomb's law and say Coulomb's law, we must speak about the relationship here. However, start by saying that it is the magnitude or the magnitude of what? Of the electrostatic force, of the electrostatic force, which is exerted, static force exerted by 1 point charge, okay, by 1 point charge on another, okay, on another is directly proportional, let's look at that now, directly proportional to what? To the product of the magnitude of their charges, to the product of the magnitudes. So we can take this down here as well here, to the magnitudes of the charges, right, of the charges. Now, and inversely proportional to the square of the distance between them, to the square of the distance between them. Do not forget the square there. between them. What you are basically saying here, you are saying F equal to K Q1 Q2 over what? Over R squared. That's how you state Coulomb's law. We then now look at 7.2. It says state whether the charge on sphere M is positive or negative. So we go back to our diagram now. We were told that charge N is positive, so this charge is positive. All right, this charge is positive, so charge N is positive. Now we are trying to pull M down, so for M to be pulled down, M must be attracted to what? To N. And then we know that if N is negative, there will be a what? A force of attraction. So M here has to be negative so that it can be pulled down to what? To N. So hence our answer, if we come here, it is going to be what? It is going to be negative. So our answer is negative here. I'll just take it down. It is negative for 1 mark. Right, we then move now to 7.3. 7.3, we are looking for what? For a free body diagram. A free body diagram for which sphere? For sphere N. So if we are looking for a free body diagram of sphere N, we now know that M is what? Is negatively charged. So meaning that if M is negatively charged, there will be an electrostatic force. There will be an electrostatic force, which is what? Which is Fe between M and N, and therefore N as well, it is what? Being pulled downwards by Fg. So this is our free body diagram here. You can even write weight here. You are welcome to do that. You still get 2 full marks. And therefore now, let us go to question 7.4. With 7.4 now, we are calculating the magnitude of the charge on sphere M. So we are looking for the magnitude of the charge on sphere M. What do we then know? We are given the charge of what? Let me just take it down. We are given the charge of what? Of sphere N, which is given as 8,06. We can just verify it that side, times 10. Just go and verify it. It's times 10 to the power. It is times 10 to the power negative 8 times 10 to the power negative 8. So we are given that charge times 10 to the power negative 8, okay? And then we are also given here, we are given the mass of what? Of N, which is the same as 2,04 times 10 to the power negative 3, which is in what? In kilograms, all right? And therefore now we are tasked to look for what? For the magnitude of what? Of the charge of M. So what we can do is we can look for the force of gravity. We can look for the force of gravity. Now the force of gravity would be Fg equal to M times the gravitational acceleration. This is for N, remember. So here what do we have? We have M as what? As 2,04. We are going to multiply this with 9,8. And therefore we go to our calculator here. We go to our calculator. In fact, it is not 2,4. Do not make this mistake as well in the exam. It is not 2,4. It is 2,04 times 10 to the power negative 3, because I can see it here. And then we have 9,8. Right. And then from here, what do? We go to our calculator from here, and we say, we want you to see this. Therefore, we have 2,04, which is exponent minus 3. I am multiplying that with 9,8. What am I going to get then? I'm going to get 0,019. So we can say 0,02. So I have 0,02, which is newtons then. And therefore now I can go and calculate I can go and calculate the charge. So I have my formula as F equals to K here, Q, we have mass, which is M in fact, not mass, and we have Q for N, and therefore we divide by what? By R squared. Okay, so now we must equate the what now? We must equate Fg because we know our force already. So if we know our force, we are going to say this side, what do we have? We have, what do we have this side? We have 0,02 equals to 9 times 10 to the power 9 in the bracket. We don't know Qm, that's what we're looking for, and therefore we say Qn was given to us as 8,6 times 10 to the power what? To the power -8. All right, the distance in between was given as 0,3, and therefore this will be squared. So what do we then do now? We can multiply the two, 0,02, 0,02, and what? And 0,3 squared, and therefore we can multiply 9 times 10 with what? With 8,6 times 10 to the power -8. If we do that, and then we are going to expose Qm, we are going to have Qm now. Qm will be equals to, if I do the 2, will give me an answer, and therefore I have the 2 as well. I divide by the answer I'm going to get. What am I going to get here? I'm going to get my Qm as 2,3, which is times 10 to the power negative what? 6, to the power -6. So what I have done here is I have taken 0,02, I multiply this with what? With 0,3, which was squared. What am I going to get? We can try that. You'll see. What am I going to get there? I am going to get, if I say 0, in fact I can say 0,3 squared, right? I multiply this by 0,02, and therefore I get my answer there, which is what? Which is 0, 0, 0, just verify our answer, 0,018, 0,018. Just have to verify that, 0,0018, 0,018. Okay, and therefore if you multiply the two as well, you get the answer. You divide by that, and therefore is going to give you what? Your mass as what? As 2,33 times 10 to the power -6. We can't forget the unit. It is what? It is kilograms. That's how you do 5. In fact, not even 5. That's how you do 7.4. Question 7.4. Okay, let's move now to question 7.5. 7.5, we are told that, in fact, we are asked, how does the electrostatic force that sphere M exerts on sphere N compare to that exerted by sphere N on what? On sphere M. With respect to, we have to look at the magnitude, and we have to look at what? At that the direction. Right, so here if you can just look at these two spheres, you will realize that these spheres are not moving, and if they are not moving, it means that their magnitude is what? It's equal. Their magnitude is what? It's equal. So we can say magnitude, it is what? It is equal. So magnitude, it is equal. We have equal what? Equal magnitude. But with direction now, it can't be the same. Can't be the same. Why? Because we have a force of attraction. So it must be what? It must be opposite direction. It must be opposite direction. So it must be opposite. That is opposite. You can write opposite here. Direction. Or because you are looking at M, M will therefore do what? The force that is exerted there is going to go upwards, or you can just write upwards, and therefore you are correct as well. For 2 marks, magnitude we said equal, and then direction we said what? We said opposite, or you can say upwards. We are now looking at 7.6, but I can see that 7.6 we are given a statement here. Let us just go through it. It says point X is 0,1 vertically below the center of sphere N. Okay, so we can see the distance here that is given as shown below. So we have sphere M, sphere N, and sphere X here. In fact, this is point X. All right, so you'll realize that the distance from M to X, it can't be 0,3. It must be 0,3 plus 0,1, which will give me 0, what? 0,4. 0,4 meters. Okay, now let us go and check if we are tasked to answer this question. How are we tasked to answer this question? Oh, calculate the net electric field at point X. So we're looking for the net electric field. I think here the best thing to do, you go to your formula, but because you are looking for E net, you can say that E here equal to what? Equal to KQ over what? Over R squared. You do get a mark for that. However, remember you're looking for E net here. So you can say E net, okay? You're looking for the electric field, the net electric field. So E net, right? Because you're looking for 2 here, so the point is what? Is point X. So you are going to say equal to, you have what? You have KQ, we can start with what here? We can start with KQM, all right? Over what? Over R squared minus KQ, Q what here? QN. But remember, our point of reference is what? Is X. It's X here, so we have R squared. So we come here and say, we know that E net here, E net, our K is 9 times 10 to the power 9, all right? Do we know the charge of M? We know the charge of M. We have calculated the charge of M, so this will be 2,33 times 10 to the power. This was it negative 6? Negative 6, and therefore over the distance from QM to X, we said is 0,4. 0,4, don't forget that, and then it is squared. Okay, minus, we know that K is constant, 9 times 10 to the power 9. We can just make this one visible here. So we have 9 times 10 to the power negative 9. 9 times 10, in fact, not negative 9, 9 times 10 to the power 9. 9 times 10 to the power 9. Let's fix that quickly. So it's 9 times 10 to the power 9, all right? And therefore, do we know the charge of N? The charge of N was given to us before as 8 times 10 to the power negative 8 to the power negative 8, all right? And then the distance from N to what? To X is 0,1, which was given to us there, squared. Okay, let's fix this before. So we say this is what? Is 8,6 times 10 to the power negative 6. Aha, we need to fix that. We had to fix that. So this is 8,6 times 10 to the power negative 6. Okay, so we have that. Right, now we have all the numbers there. So we have E net, which will be equal to, we take our calculator, we punch here, 9 times 10 to the power 9, we multiply by 2,3, 3 times 10 to the power negative 6, we divide by 0,4 squared, minus 9 times 10 to the power 9, and therefore we go to times by 8,6 times 10 to the power 6, you divide by 0,1, close the bracket and the squared. If you punch this in a calculator, your answer here should be Your answer here should be 5. In fact, let's start with the answer that you're going to get here first. You're going to get 13106. I have 2 here, comma what, comma 5, minus, and then this side here we are going to get 7, and then 400. Check your calculator again. Here we have E net. Okay, we have E net here, and then E net, this will be E net. I'm gonna just punch the numbers that I have here, and after punching these numbers, this is what I'm going to get. In fact, let's punch it together and see if we're gonna get the same answer. Okay, so now we can just use this, put this somewhere here where you can see, okay, these are my numbers here, but I need to see the number here, so I can come here and say 13106. Be careful as you're punching here, because if you make a mistake, you're going to lose the marks. So it's minus. Since I've done that, I want you to see is 77400, and then the answer we're supposed to get here is 53. It's 53, so we can take it down here. 53. It's 5366, and therefore 2,5. 2,5, and then our unit here, we know that is NC. Okay, it's fine. So that's the answer we're supposed to have. But remember that we are only getting this answer here. We're only getting this answer here. If I come and say upwards here, it means that I chose upwards as what? As positive. Grade 12s, that's how we summarize, or that's how we answer